Hello, my name is Rodrigo Garrido, and this short video is intended to give you a briefing about this article written by Pablo Miranda and myself in 2004 and published by Elsevier in Transportation Research Part E. Let's take a look at the highlights of this article. First of all, the paper deals with a simultaneous approach to incorporate inventory control decisions into more strategic decisions, namely facility location problems. We developed a simultaneous model that considers stochastic demand as well as the risk pooling effect, which I will describe later on. The resulting modeling structure is a nonlinear mixed integer program along with a heuristic method that allows easy finding of feasible solutions for a relatively large problem. By using this approach, you can get significant cost reductions compared to more traditional approaches, especially when the holding costs are high or demand is highly variable. Let's take a look at the graphic representation of the distribution network. Let's start by assuming we have a bunch of customers, people, retailer, whoever, who demands a certain product that we produce in a single plant. We start by building distribution centers and filling them with enough merchandise to serve the customers that have been assigned to this distribution center. You may have distribution centers of different sizes and located in different places, but the idea is that all of them must be supplied with enough merchandise to serve all the customers. We know for a fact that inventory costs depend, among other things, on the standard deviation of the assigned demand. For instance, in the first case, that would be the standard deviation of the assigned demand, and so on and so forth. We can clearly see that if we modify the assignment of customers to distribution centers, we would have a different cost structure. For instance, if we got rid of the second distribution center and reassign its customers to distribution center 1, this would be the new standard deviation for distribution center 1. The standard deviation for the third one would be the same because the very same demand was assigned to it. So by doing that, we decrease the total distribution cost. Why? Because previously the safety stock kept in the distribution centers was larger than the one we have with the new assignment. So the first idea is, why don't we go all the way to just one single distribution center? That's doable, but probably it's not convenient because many customers that are located far away from the distribution center will have considerably large distribution times. Namely, the level of service of your network will decrease. So there must be some kind of compromise between the inventory cost and the level of service. So we may search for many configurations and among those try to find the one that on one side minimizes the inventory cost but at the same time keeps a level of service that you consider appropriate for your distribution center. There are many combinations, so it's a very difficult problem to solve. And so what we did in this article is to find a way to do this. So that was done through a nonlinear mixed integer model that finds a near optimal solution. The costs that were considered in this model were installation for the facilities, transportation, ordering and holding costs, as well as the risk pooling effect. That was that effect that the lower the number of distribution centers you have, the lower the inventory cost. So, but you can easily imagine that if you have many customers, the problem would be out of hands because there are way too many combinations. And we designed a model which is an extension of an already NP-hard problem. So you can imagine that the problem that we're presenting here is even harder to solve. That no over-the-shelf software will give you an optimal solution. So we had to design our own heuristic based on Lagrangian relaxation that gives you a feasible solution in a reasonable amount of time. The main findings of this research were synthesized in three families. First of all, the cost reduction is higher when the holding cost or the ordering cost are higher, or the lead times are longer, or the level of service is higher. Also, when the demand is highly variable, the cost reduction is better with this approach. Secondly, the complexity of the problem precludes the use of exact algorithms, and we need a heuristic method, and we offer an efficient method to find near optimal solutions. And finally, this approach may be very helpful for decision makers in designing distribution networks, especially when dealing with supply chains that distribute products that are time sensitive. For instance, the food industry or electronic devices, etc. If you want to read the whole article, go to the Elsevier website and look for this paper at the bottom of the page. Thank you very much.